In this video, we're going to talk about 8.3 Objective 2, where we compute and interpret confidence intervals for population proportions. Let's look at number 1, determine whether the given statement makes sense or does not make sense and explain clearly. Our survey found that 64% of voters approve of a particular policy of the president with a margin of error for 95% confidence of 2 percentage points. Therefore, there is only a 5% chance that the proportion of approval among all voters differs from 64%. No, that's not what it means. So the confidence level is not a probability that this number is correct here. That's not what it is. You are so let's just keep going. Determine whether the statement below makes sense or does not make sense and explain clearly. A newspaper publishes an article stating that based off of survey results, 72% of local residents oppose an increase in the sales tax. With a margin of error of 4 percentage points, we can therefore express the confidence interval as 68% to 76%. That's right, because 72% minus 4% is 68%. 72% plus 4% is 76%. So that makes sense. The statement makes sense. The margin of error was added to and subtracted from the sample proportion to construct the confidence interval. The newspaper provided a snapshot illustrating poll results from 1,910 professionals who interviewed job applicants. The illustration showed that 26% of them said the biggest interview turnoff is that the application did not make an effort to learn about the job or the company. The margin of error was given as plus or minus 3 percentage points. What important feature of the poll was omitted? It doesn't tell us the level of confidence, so we don't know whether that margin of error was calculated with a 95% level of confidence, a 99% level of confidence, 90% level of confidence. What's going on with that plus or minus 3 percentage points? Where did that come from? Assume that the population proportion is to be estimated from the sample described. Use the sample results to approximate the margin of error and 95% confidence interval. So let's go ahead and let's do this with a calculator. These are all dash T problems. So stat tests, and then we want to find a 1 prop z interval, which is down here. There it is. And they did not give us x, but they gave us x over n. So if p hat equals 0.3 is x over n. 0.3 is equal to x over 550. X equals 0.3 times 550. And x always has to be an integer, or not an integer, a whole number. So you're going to have to round that if you get a decimal, because we round this proportion value sometimes, and we're going to have to go to the nearest x value that we can, because you can't have a fraction of a response from a person. X and n both have to be whole numbers. The level of confidence here is 95%. We're going to calculate. There's our p-value of 0.03, and we have an n of 550, and our p is between 0.262 and 0.338, and so 0.383 is our margin of error. So let's to go to 4 decimal places there. All right, let me go ahead and show you how to calculate this by hand without, not by hand with the calculator, but without going into the z interval. So your margin of error is your critical z value, which we've talked about already for 95% is 1.96, times the square root of p hat times 1 minus p hat over n. So 1.96 times the square root of 0.3 times 0.7 divided by 550. And there's how we get the margin of error of 0.0383. And we're going to take that margin of error, and I'm just going to call that E for margin of error. I'm going to take 0.3 plus E, and I get this number down here, 0.3 minus E, and I get this number over here. I'm just going to be using the one prop Z test, but if you don't have that on your calculator, you can go ahead and use this formula method here as well. All right, let's go ahead and look at stat tests and go back to one prop Z interval here. And we're going to have 420 times 0.35, whatever that is, that's 147. And we have 420, and we have a 95% level of confidence. So that gives us to 3 decimal places 0.304, 0.396, and our margin of error here is 0.0456. And now we have 5,500 times 11%. This is 5,500. And we have a 95% level of confidence. And 3 decimal places, 0.102, 0.118. They don't ask us for E this time. And 65% of 1,400. N always has to be large to be able to do these because it's always a Z value. So we're not going to get small sample sizes when we're getting these p hat calculations. So 0.625, 0.675, and 0.02. And we have 123 for X out of 157 for N. And margin of error we'll find in just a second, but this is 0.719, 0.848. P hat to 3 decimal places is 0.78. Let's go to 4 decimal places. 3, 4, like that. And so we want um, 0.064. I'll do the subtraction here. 0.848 minus 0.7834, 0.646. If we want to do that calculation, like I showed you before, we'd have to have x over n was 123 over 157, and then q hat is going to be the remaining 34 over 157 divided by 157, 1.96 times the square root of big fraction here, 123 over 157 times 157 minus 123, divided by 157 divided by 157, and my margin of error, it's a little bit off, 0.0898. Oh, it's off because I typed that wrong. Come on, get in here. There we go. That was right before. 6, 4, 3. And take my margin of it, my p hat, which was 123 over 157. We're going to add to that 0.0643. Excuse me. And we get 0.8478, which rounds to 0.848. And if I do this and change that to a subtraction sign, you get 0.719. That's how we would do that without the one prop Z interval. Okay, research poll included 1,670 randomly selected adults who were asked whether global warming was a problem that requires immediate government action. Results show that 958 of them indicated that immediate government action is required. A news reporter wants to determine whether the survey results constitute strong evidence that a majority, more than 50% of people, believe that immediate government action is required. Complete parts A through C below. So we had 958 out of 1,670 respondents with a I believe this was a 90% or 95% level of confidence. Does not say. C. Read that again. Research poll indicates that 1,670 randomly selected adults asked whether the global warming requires immediate government action. Results show that 958 of those surveyed indicate immediate government action is required. A news reporter wants to determine if the surveys offer strong evidence that the majority of people believe business. Okay, construct a 95% confidence. There it is, 95%. So our p hat is 0.574, and we have 0.550 to 0.597. And because everything in our confidence level is greater than 50%, then yes, because the range of values in the confidence interval include only values greater than 0.5, it appears that the majority is in favor of immediate government action. Prior to a statewide election, 3 polls are conducted concerning a particular candidate's popularity. In the first poll, 740 of 1,520 votes favor the candidate. In the second, 1,255 of 2,510 favor the candidate. And in the third poll, 1,802 of 3,500 voters favor the candidate. Find 95% confidence intervals for the proportion of voters who favor the candidate in all 3 polls. So let's just start with the first poll. And we have 740 out of 1,520. And we want 3 decimal places, so 0.462 to 0.512. And then the second poll was 1255 out of 2510. This is 0.480, 0.520, and the last one was 1802 to 3500. This is 0.498 to 0.531. And this just appears to basically be what we would say politically would be like a dead heat, that basically you see 50% is in all of these intervals here. Since all of these confidence intervals include values less than 0.5, the candidate cannot be confident of winning a majority. It's not like the last problem where the confidence intervals showed only values bigger than 0.5. And we could say, yeah, it seemed like a majority of the people supported that issue. We can't say even here that a majority of the people don't support the candidate. We could say it's a toss up right now, whether they support or don't support the candidate, because we have all of the polls include values above and below 0.5. All right, so that's it for this video. We will come back next time and we will talk about 8.3 objective 3. See you for the next video.